Hey guys, welcome to Oddly Specific Godot Tutorials, Episode 2. In this episode, we'll be creating a boat. It's going to be pretty similar to the helicopter, the same sort of physically simulated thing. Here's how it's going to work. In order to keep it afloat, we're going to simulate each of these four corners as if it floated. So if it goes below the water level, we're going to apply a proportional upward force. The force is only applied if it's underwater, which means it will consistently stay floating on the surface. The player is going to be able to apply a directional force forwards and also a rotational force side to side along the y-axis, but only when they're moving forward. First off, create a rigid body, name it boat. Add a mesh. As a child, create single convex collision sibling for all of the parts of the boat that you want to have collision. I think I've got to add a smiley face. That's better. That's kind of weird. Okay, add a script to the boat. And the first thing that we are going to set up is mouse controls. Go ahead and capture the mouse with this line of code in funcReady, and then we are going to use input event. If event is input mouse motion, then mouse movement plus equals event.relative. Then come back up to the top and declare the mouse movement variable to be an empty vector2. Now we need to set up the camera so that we can use the mouse controls to rotate it. Get a spatial, call it H. This is going to be the horizontal movement of the camera. Add a spatial underneath this one, call it V. This is the vertical movement of the camera, and then add the camera as a child of this. Drag the camera back to where you want it, and as you can see, if we move V around, it controls the vertical rotation of the camera here, and if we move H around, it goes back and forth there. And we can layer these two to ensure that the camera doesn't get twisted around and sideways. In physics process, if mouse movement is not an empty vector2, so if we've received some mouse movement, then we want to add mouse movement.x to rotation to h rotation degrees.y, and then hv rotation degrees.x we add mouse movement.y. So the up and down movement rotates it around the sideways axis, and the side to side movement rotates it around the up and down axis. After we set the rotation, we want to set mouse movement back to an empty vector2, since we've already used it. Actually, both of these have to be negative. We're subtracting the mouse movement, not adding it. Now we're going to go ahead and set up our demo scene so we can properly test. Create a new scene, add a spatial as the root node, and rename it world. Add a mesh instance as a child of the world, and name it water. Set the mesh to a new plane mesh, and in material, change the albedo to whatever watercolor you prefer, and then go into flags and turn transparent on. Then you can go back into the albedo and change the alpha so that the water is partially transparent and we can see parts of the boat that are underneath the water. Then scale water up to be absolutely gigantic. Like beyond all reason gigantic. Go back to world and link the boat scene. And now your mouse movement should work properly. However, you're allowed to loop over the top like this, and we don't want that. Because we never need the camera to go underneath the water, we can actually limit the movement to -90 degrees here, where the camera is straight above the boat, and then 0 degrees here, where it's straight behind, instead of the normal limiting it to straight up and straight down. If hv.rotation degrees.x is less than or equal to -90, then we want to set it to 90. And then copy and paste that, switch it to greater than, and replace -90 with 0 on both lines. The mouse movement is now properly restricted. Now we're going to set up our key bindings. Go into Project, Project Settings, and Input Map. Add W, A, S, and D, and then bind each key to that letter in the key bindings. Now, if input.is action pressed W, then we want to move the boat forward. We're going to add central force. Global transform.basis.xform just ensures the vector we're passing is translated into the local coordinate system, meaning that the boat will move to its forward and not the world's forward. And then we just say vector3.forward. I think we should set our acceleration to about 20, so just multiply that vector by 20. And then copy and paste this, change it to LF, S, and then we want to move backward 10. Inside of is input.actionPressed W, add is input.actionPressed A, and then write add torque. We want to rotate around the y-axis, and then copy and paste this, say D, and make it negative. Then copy and paste this whole code and put it in S. So now, if you're moving, it checks to see if whether or not you're trying to turn. Now we need to simulate the flotation so we can see if this movement's actually working. Go into Boat, add a new child node, and just add a spatial and name it floaty. Drag it to one of the four corners, hold Control to snap, and then duplicate it, duplicate it, duplicate it. Make sure there's one in each corner. You should have 4. Check to see if floaty's global transform.origin, so its global position, .y, is less than 0. If it is, then we want to add force, and the first argument is the vector for the force we apply. We want vector3.up times 20 times negative floaty.globaltransform.origin. Basically what this does, the lower it is, the more force it's going to apply to make sure that the boat balances itself out. And then the second argument for this function is the position at which we apply the force. We want to say floaty.globaltransform.origin minus globaltransform.origin. This is going to get its position relative to the boat's position. Copy and paste that 4 times, and then add the numbers so that it runs this code for each floaty. It should now float, but there is a slight problem. Because we don't have any linear damping, the boat will bounce higher and higher as it goes, and then sink all the way under and hop back up. So go to the boat, and then change its linear damping to 1. While you're down here, also change the angular damping to 1, so that the boat doesn't spin forever. Now, the boat should be floating properly. In order to tell whether or not our movement code is working, we're going to need to add a couple more mesh instances to this scene. I colored mine like crates, because why not? Just place a couple of them around the place so you know whether or not you're actually moving. We're going to need to turn this rotation up a little bit. And after that, everything should be working smoothly. The last thing that we want to do is make sure that it only runs the movement code if we're in the water. So if globaltransform.origin is less than or equal to 0.1, globaltransform.origin.y, and then just tab all of this code forward, and then yeah, hit run. A couple last minute things. You're going to want to turn the angular damping up a little bit to at least 2, and if you change the weights on the floaties around, just tweak the movement a little bit, it'll feel a little better. I've also set up this this demo scene. It's got some crates that float that you can collide with, and a ramp you can go off. So yeah, that's a TSCN file. I will leave that in a link in the description. Hope you guys enjoyed.